Welcome back to Defense Tech World. Today, we're exploring one of the most recognizable and historically significant missile systems of the modern era, the Scud, R-17. These weapons aren't just metal and fuel, they're the result of decades of engineering, strategy, and technological evolution. Whether used on the battlefield or as tools of deterrence, missiles like the Scud have changed how nations think about defense. So, let's dive into what makes these systems so fascinating. A missile is more than just a rocket. It's an intelligent, highly engineered weapon designed to reach its target with both speed and precision. Every missile can be broken down into three essential components: the propulsion system, the guidance and control system, and the warhead. Let's start with propulsion. This is what gives the missile its thrust and sends it hurtling through the sky toward its target. Some missiles use solid-fuel rockets for instant acceleration and reliability, while others rely on liquid fuel engines, turbojets, or ramjets for extended range and control. Modern missile systems can travel hundreds or even thousands of kilometers. Some reach hypersonic speeds, more than Mach 5, allowing them to strike before the enemy can react. Next is guidance and control, the brain of the missile. Advanced systems use radar, GPS, infrared sensors, or laser targeting to navigate accurately. Real-time control adjustments help the missile stay on course, even under harsh environmental conditions or when facing countermeasures. Finally, there's the warhead, the business end of the missile. Depending on its mission, this can include conventional high-explosive payloads, kinetic penetrators for hardened targets, or non-lethal payloads for training and testing. Some missiles are designed to intercept aircraft or neutralize incoming threats mid-air, while others are built to strike ground or naval targets with surgical precision. Storage and safety are just as critical as launch operations. Missiles are stored in underground silos, mobile launch vehicles, or naval vertical launch systems. Specialized crews constantly monitor temperature, fuel stability, and electronic safety locks to ensure these powerful systems remain secure until the moment they're needed. Now let's look closer at the star of today's episode, the Scud, R-17 missile. Originally developed by the Soviet Union during the Cold War, the Scud became one of the most widely deployed short-range ballistic missiles in history. Its straightforward, rugged design allowed it to be produced in large numbers and exported to multiple countries. The Scud typically uses a single-stage liquid fuel rocket engine and can carry various warheads, including high-explosive and fragmentation types. Its range varies depending on the variant, with some capable of striking targets over 300 kilometers away. While not as precise as modern guided systems, its mobility and ease of deployment made it a powerful tool for both offensive and defensive strategies. The missile is launched from a transporter erector launcher, or TL, a vehicle that can carry, raise, and fire the missile from virtually anywhere. This mobility made Scud systems harder to detect and target, giving them strategic value far beyond their range. The Scud's legacy extends beyond technology. It influenced the design of many later missile systems around the world. Even decades after its introduction, derivatives and upgrades of the R-17 remain in service, proving how durable and adaptable this platform is. From iconic systems like the Scud, to advanced precision weapons like the Tomahawk and BrahMos, and on to the hypersonic missiles shaping the future, these technologies have redefined speed, accuracy, and deterrence on the global stage. But with such power comes responsibility. Missile technology is more than just a tool of war. Stay tuned to Defense Tech World.